To convey or not to convey is never the question. Parts have to get places, and conveyors are a simple but versatile way to do that. I've always considered conveyors to be among the simplest things in automation to program, but truth be told, they can get a bit complex. Whether that's due to necessarily complicated automation or unnecessarily simple programmers, I'll leave up to your discussion in the comments to decide. Today we're looking at queuing. Let's get into it. So what is queuing? Queuing is lining up parts in a first in, first out system. Here I've got conveyors drawn as boxes. These are all intended to be the same kind of conveyor over and over again, with the same kind of part on them over and over again. So here's a part, and this is intended to be the conveyor. This is showing every conveyor has a part on it, is occupied. This is a type of conveyor where we want to control each box or each pallet, each part individually. Rather than crashing them into each other to make a line, we're stopping them when they see a sensor. If we look at one conveyor, this is intended to be, could be a roller conveyor or a belt conveyor. I usually see this type of thing as a roller conveyor. And whether that has an AC drive on it or a DC drive, we're just going to assume for our purposes that the PLC has a simple output to tell it to run. In this case, they only run forward. So it's just on or off, run or don't run. And then we only have one input, and that's that sensor. As I've done before, I've got simulation in the background to make this kind of work like a real system so that we've got something to visualize while we're programming it. I'm not going to go into that. As always, you can download the sample file. I'll have a link in the description, and you can play with that to your heart's content. Code Assist is free and available online. Our real world is going to be limited to these variables here as far as our programming is concerned. I've made some global variables, and it's that input and output for each one of these 4 conveyors, 1, 2, 3, 4. You'll see this terminology a lot, but people will use other terminology as well. So PP is part present. Sometimes people will call this a stop eye because it tells the package when to stop. Sometimes people will call it a PE for photo eye. I don't find that to be especially helpful because it's describing the sensor rather than what the sensor is looking at, but it is very common. And if we have a conveyor that's going forward or reverse, we would probably have another stop eye here. So we would have a forward stop eye and a reverse stop eye, and part present may be a combination of those two things, just like an imagined idea inside the PLC. Or we might have a third sensor, could even be poking up through the rollers, could be at an angle here or something that tells us part present. So that's all very application specific. So for this, we're just taking it really simple. Everything's going straight, one sensor, one output to drive it. So let's dig into the code. This is probably just as simple as you expected. Why don't I run this once so that you can see what it looks like, and then we'll look at the code. Okay. So here we've got the simulation, and as I look at this, I want to clarify that this box here is intended to be a physical real box. So that is the box as far as the simulation is concerned. It's not the box that the PLC sees. This green light means that this photo eye sees the box, and that is the input that the PLC sees. That's how this is modeled. I can click on any of these conveyors to add a box or remove a box just so that we have something to play with. And if I empty it all out, you can imagine if I put a box in the beginning here, if we're queuing, that should go forward until it can't go forward anymore. So I'll put a box there. The animation's a little choppy because my computer's doing too many things, and Code Assist isn't particularly efficient about this kind of animation. Okay, so that went to the end and then stopped. In any situation where you've got conveyors, the first conveyor and last conveyor are always going to be a little different. That's absolutely true here as well. In this case, I'm assuming that a person is loading and unloading, and that's me with the clicker, obviously application dependent. So let's add another one, and that should stop at 3. Add another one, that should stop at 2. And then if we add a final one, this shouldn't go anywhere because there's nowhere for it to go. Now, if I take this box off of 2, we can imagine this should backfill in there, and then we could add another box to 1. Actually, I could take one off of 3, and we can move forward Note that the way that moved forward is 2 moved first and then 1 moved. And that's pretty typical. We could change that programming if we wanted to, but 2 moves first, then 1. The idea being, if we can see something at this photo eye, station 1 should not feed forward because this station is occupied already. And we can see something at this photo eye until that part is almost all the way over to station 3. So again, very typical. Let's get out of the simulation and just talk about this program a little bit. Conveyors are often treated as an individual thing from a programming standpoint. So we're not looking at this usually as a whole system and trying to make like an overarching program that considers that whole system at the same time. We usually make a program that considers one station at a time. And then those are like a bunch of little programs, if you want to think of it that way, inside of a bigger program. In this case, if I have a part on station 1, meaning I see this photo eye, and I do not have a part at station 2, I don't see this photo eye, then that part should move forward. We want to turn on the output for conveyor 1 to run. And we want to turn on the output for conveyor 2 to run as well so it can receive. You'll notice in the outputs here, I made an intermediate state that says load conveyor 2. And this is pretty typical because we have multiple conveyors controlling the run state of a single conveyor. For example, conveyor 2 should turn on when it's receiving from 1 or when it's sending to 3. So if I put the output right here, then I couldn't put it somewhere else. So that's why we have this intermediate state, this state of loading conveyor 2. When do I want that to happen? Well, when I see a part here, and when I don't see a part here. Pretty simple. And then I want that to latch itself on until we see this part happen at station 2. When those two things are true and false, then load conveyor 2, and then ignore the sensor for conveyor 1 until we really get all the way there. Because this box or pallet or whatever will pass this photo eye before it gets to position here. What happens when we're in that state? Well, I've got some output rungs as well. Conveyor 1, conveyor 2, conveyor 3, and conveyor 4. And of course, the end states again are going to be a little bit different, so that's no surprise. And again, conveyor 2 should be running when we're loading conveyor 2 or loading conveyor 3. That's the in feed and out feed of conveyor 2. And this pattern just repeats exactly. So if there's something at conveyor 2 and there's nothing at conveyor 3, load conveyor 3, keep that latched on until it gets to conveyor 3. Same with conveyor 4. And then again, the outputs are very repetitive as well. When we're loading conveyor 2, then we're going to run conveyor 1, which is getting rid of this. In a real situation, maybe there's an in-feed for conveyor 1 also. I don't know. Again, I just am assuming that an operator is putting stuff on and taking stuff off. So let's go back to the simulation. We'll just see this run while we can see the bits again. So let's take this just one step at a time. I'll leave a couple boxes here so that things aren't running beyond the one step at a time. So if I put a box in station 1, we're going to see this sensor turn on, which should turn on this rung, which will turn on this output. And again, we'll latch that rung in. So let's watch that happen. It's all pretty straightforward. Let's try the same thing going 2 to 3. Again, that's blocked right now, but I'll just remove this box so that can run. So that's what's stopping conveyor 3 loading from happening. Just remove that box. And same thing for number 4. We'll turn that on. So I know this is super simple. I've got a whole bunch of variations and things that are going to make this more complicated coming up in the next few videos. So stay tuned. Hope to see you there.
Thanks, John. The weather is beautiful here at Breen Machine. Looking at the map, we can see a massive subscriber front coming right through here, with a high chance of likes and shares. And I would bet you we'll see some comments in the near future as well. Don't miss the great weather. Click here to keep it coming. Back to you, John.